Hi children, welcome back to another video about chemistry lesson grade 9 small concept. Here it is, what is a mole? The mole is a counting unit in chemistry, that abbreviated or expressed in MOL, mole. It is defined as the number equal to the number of carbon atoms is exactly 12 gram of pure carbon 12 atom. A mole of a substance is the amount that contains as many elementary units as the number of carbon atoms in 12 gram of carbon 12 atom. This is the definition of mole. Okay, once again I am telling that a mole of a substance is the amount that contains as many elementary units as the number of atoms in 12 gram of carbon 12 atom. It has a particular value, that is 6.022 into 10 to the power 23. This value is called Avogadro number or Avogadro constant. But this is honor to his contribution to chemistry. That is an Italian scientist, Amedeo Avogadro. The honor of him, this constant give his name. Okay, Avogadro number. And 1 mole of anything consists of 6.022 into 10 to the power 23 unit of that substance. Just like a dozen, you know that 1 dozen contains 12. So a mole of egg is 6.022 into 10 to the power 23 eggs. The same like if 1 mole of hydrogen, it contains 6.022 into 10 to the power 23 unit. That's the about the mole. So I think you understand that the definition of mole is the number equal to the number of carbon atom, exactly 12 grams of pure carbon 12 atom. We have to define what is Avogadro number. Avogadro number is the number of particles found in 1 mole of a substance. It is the number of atoms in exactly 12 grams of carbon 12 atom. This is experimentally determined value, and the value is this one, 6.022 into 10 to the power 23. The Avogadro number is the number of atoms in a 12 gram sample of carbon 12 atom. Okay, the definition of mole and Avogadro number or Avogadro constant, remember. Here it is some examples. We calculate the mass of 3.011 into 10 to the power 23 number of oxygen atom. Okay, how many moles of oxygen are there in this much number of the number of moles is equal to, here it is number of particle. This is the number of particle divided by atom Avogadro number. You will get 0.5 moles of oxygen atoms are there. And same like the number of moles is equal to mass divided by relative molecular mass. Did you remember what is relative molecular mass? The sum of relative atomic masses of the element of a compound. Here it is how many moles are there in 15 grams of calcium carbonate. If I look at the ARS, relative atomic masses, relative atomic mass, then added them together to find the molecular mass. The molecular mass, carbon, you know that atomic mass is 40 and carbon 12 and 16 is the atomic mass of oxygen. So here it is calcium carbonate, 1 atom of carbon, calcium and 1 atom of carbon and 3 atoms of oxygen. So 40 plus 12 plus 48 will come. So this will be 100 gram. So calcium carbonate, the mass 1 mole of calcium carbonate has 100 gram. So number of moles in 100 gram of calcium carbonate is equal to 15 divided by the mass divided by molecular mass, that's equal to 0.15 moles. Next one is molar gas volume. What do you mean by molar volume? 1 mole of any gas at room temperature and pressure has a volume of 24 decameter cube. This is called the molar volume. For 1 mole of any gas or vapor occupies 24 decameter cube at room temperature and pressure. RTP, this is room temperature and pressure. Room temperature is considered as 20 degrees Celsius and atmospheric pressure is 1 atmosphere, that is 760 millimeter of mercury. So it means 1 mole of oxygen gas is 24,000 centimeter cube, that is the volume. Or 3 mole of oxygen gas can 3 multiply this much at RTP, room temperature and pressure. So 24 decameter cube, that is 1 mole, is called molar volume of gases. What molar volume means, 1 mole of any gas at room temperature and pressure has a volume of 24 decameter cube. This is called molar volume. See, here it is 1 mole of different gases. Any gas they are telling, see here it is 1 mole of hydrogen gas. The mass is 2.0 gram. It has a volume of 24 decameter cube. And here it is of 1 mole of oxygen. The mass of 1 mole of oxygen is 32 gram. It has also same 24 decameter cube, the volume. And here also 1 mole of carbon dioxide. The mass of that one is 44 gram. It contains 24 decameter cube, that is the volume. So this is called molar volume. Now there is some calculation involving the molar gas volume at room temperature and pressure. The molar gas volume is 24 liters per mole or mole, okay. And then worked out, calculate the volume of 0.025 moles of oxygen. 1 mole is equal to 24 liters. And then 0.025 mole, how much is that? 0.025 divided by 1 by 24. It will get 0.6 liters. And here it is, calculate the number of moles and 72 liters of hydrogen. 72 liters of that is 72 divided by 24 into 1, that's 72 liters. That is equal to 3 moles. It contains 3 moles. How much moles here you have to find? Here it is given 1 mole into this much gram. This given how much liters here you have to find. So here what is the volume of 0.03 moles of hydrogen at RTP, that is 72 centimeter cube. Okay, this way the calculations. Now next is the difference between empirical and molecular formula. I think all of you remember that. An empirical formula is the chemical formula for a compound that the atoms contained in the compound in the smallest whole number ratio. And the molecular formula, the actual formula of the actual number of atoms in the compound. The empirical formula is the simplest ratio in which the atom in a compound are combined. That is empirical. Molecular formula is the actual number of atoms that combines in a molecule. But here it is, give some examples. CP4O10. This is the empirical formula. Water, H2H2 same. In 2O4, this is the simplest ratio of the element in the compound, that is empirical formula. Molecular formula, the actual number of atoms that combine in the molecule. This is the difference between empirical and molecular formula. Now calculating percentage yield. What do you mean by percentage yield? Percentage yield is the measure of the efficiency of a reaction carried out in the lab. How much efficient that solution or the substance given. The ratio of the actual yield to the theoretical yield is percentage yield. See, this is the equation. Actual yield divided by theoretical yield, multiply 100%. That is, actual yield is the amount of product obtained from the lab, what we get in the lab. And then theoretical yield, the amount of product obtained from the stoichiometry. We have to calculate that one. Here see, methane react with oxygen, is forming carbon dioxide and water. Here known masses is 10 gram and the reactants is 10 gram, product is 19.8 gram. Moles of reactant used, CH for the mass divided by molecular mass, that is 10 divided by 16, 0.025 moles for the reactants. And the product, it is 1 mole of CH4 make 2 moles of water, and so 0.625 moles of methane makes 1.25 moles of water. And here it is, this way it is given, 6.025 into 1.25. mass of water expected. Mass of water is moles multiply molecular mass. Molecular mass of water is 18. You know that how to calculate this one. Hydrogen, the atomic mass is 1. 2 atoms are hydrogen is in 2 into 1 the 2 plus 16 is the atomic mass of oxygen. 2 plus 16 that is 18. So moles multiply the molecular mass, you will get 22.5 gram. Then percentage yield is equal to mass found divided by mass expected. Mass found is 19 gram the product, divided by mass expected, this 22.5 gram. Then multiply with the 100, you will get 88%. The percentage yield of this substance is 88%. Okay, this is the way we have to calculate the percentage yield. Now calculating percentage purity. What do you mean by percentage purity? Percentage purity is the percentage of a pure compound in an impure sample. But sometimes we will get an impure sample, we can't say that all the substances are pure. But so some of them are impure, but we have to find the percentage purity is a percentage of a pure compound in an impure sample. The equation is mass of pure compound in sample divided by total mass of the impure sample multiply with 100. But here it is say 150 gram sample of copper ore contain 87.3 gram of pure copper. Calculate the percentage purity. And this is the pure sample mass divided by the sample of copper ore, the impure sample. Multiply 100, you will get 58.2%. Here also another giving, you have a 13.9 gram sample of pure iron pyrite. You have to obtain 8.02 gram of iron oxide. This is the equation given. Actual yield 8.02. Sample of mass is equal to 13.9 gram. It's given that. And then theoretical mass you have to find. So percentage purity, theoretical mass divided by sample size into 100. But that is 12 gram divided by 13.9 into 100, 86.3%. Therefore, the percentage purity of iron pyrite sample is 86.3%. And this is about percentage purity. Now, we should remember the important equations in this lesson. Mass of 1 mole of atom is equal to atomic molecular mass, relative atomic mass in gram. A mass of 1 mole of atom is equal to relative atomic mass in grams. The number of moles in an atom, how to calculate? Mass of an element in gram divided by relative atomic mass. Mass of 1 mole of molecule is equal to molecular mass in gram. Number of moles of molecules, mass of the substance in gram divided by relative molecular mass. Mass of substance containing 1 mole of a particle is equal to molar mass. That is 24 decameter cube. That percentage yield, actual mass of the product obtained divided by theoretical mass of the product obtainable to 100. That one. This is the actual yield divided by theoretical yield into 100. That is the way we have to calculate the equations. Equations you have to, the worksheet I will give you some examples. After doing that, you should clearly understand that. Okay.